It is possible to state the relative level of formation permeability within the region of the wellbore being tested. Charts from low permeability formations, as we see here, produce buildup curves that suggest the pressure is beginning to stabilize. This is often referred to as pressure starting around the curve. These formations have very low pressure increases, if any, during the flow periods. There will be a weak blow at the surface, small fluid recovery, and fairly low flowing pressures. Charts from average permeability formations exhibit better buildup curves during the shut-in periods and some pressure buildup during the flow periods. There should be a good blow description, moderate fluid recovery, and increasing pressures from one flow period to the next. Charts from high permeability formations will have a high flow rate and a strong blow, high flowing pressures, and rapid stabilization of pressure during buildup. The one shown here stabilized at the point where the flowing pressure is almost equal to the final shut-in pressure. Significant wellbore damage exhibits low flowing pressures, a sharp pressure rise after the tool is shut in, and a short pressure transition radius during buildup, followed by a flat pressure increase. There is a weak blow at the surface and very little recovery. Fluid depletion during the test is minimal. If the wellbore cleans up during the test, then there will be a change in the character of the curves from that shown here to one we just saw. The DST may also provide us with a measure of whether the zone being tested is large or small. The evidence we use is the pressure difference between the initial and final stabilized shut-in values. If a significant difference exists, we have a reservoir of limited or finite extent. We see such an example here. The fluids produced during the flow periods have caused a measurable depletion or drawdown of the reservoir. A pressure change of 1.5% or greater is considered serious, and retesting may be warranted. A reservoir barrier or nearby production may also cause the same effect, and so some additional analysis may be required. Here we see an excellent example of a decrease in pressure levels between the initial and final buildup periods. In this case, one caused by a reservoir barrier or permeability restriction as opposed to depletion. The change in the slope of the buildup curve indicates a reduction in transmissibility some distance from the wellbore.